Could one of the world's largest volcanoes be on the verge of an explosive eruption? Yellowstone is showing signs of imminent danger, and officials have issued an urgent evacuation order. Stay tuned to uncover the alarming truth behind this crisis. Hello and welcome to our channel. Today, we're diving into a breaking and potentially catastrophic situation developing in Yellowstone National Park. After weeks of intense seismic activity and significant geothermal changes, officials have issued an urgent evacuation order. What triggered this drastic measure? How severe is the threat? And what could be the catastrophic consequences of a Yellowstone supervolcano eruption? Stick around as we unravel the scientific facts and the potential global impact of this unprecedented event. The urgency of the evacuation order is fueled by a series of alarming events that have unfolded in recent weeks, indicating that the Yellowstone supervolcano is far from dormant. Increased seismic activity and notable geothermal changes have raised serious concerns among scientists and officials, leading to the decisive action of evacuating the area. Yellowstone has always been a hotbed of seismic activity, but recent weeks have seen a marked increase in volcanic unrest. Scientists have observed ground uplift in certain areas of Yellowstone, caused by the accumulation of magma and gases beneath the surface. In the past few weeks, some areas have experienced up to 6 inches of uplift, an alarming rate that signifies the potential for an eruption. Accompanying the seismic activity are notable changes in Yellowstone's geothermal features, including its famous geysers, hot springs, and fumaroles. Geysers that typically erupt at regular intervals have become erratic, with some increasing in frequency and intensity. For example, Steamboat Geyser, known for its sporadic and powerful eruptions, has erupted more frequently than usual, reaching heights of up to 300 feet. These changes suggest that the underground heat source is becoming more active. Hot springs, which are typically stable, have shown significant temperature increases and changes in color, indicating chemical alterations in the water. These changes are caused by the introduction of new gases and minerals from the rising magma. Fumaroles, or steam vents, have also become more vigorous, releasing greater amounts of steam and gas. These geothermal changes provide further evidence that the magma chamber beneath Yellowstone is highly active and potentially nearing a critical point. In response to these alarming signs, officials have issued a series of warnings and advisories to the public. The United States Geological Survey, USGS, and Yellowstone National Park authorities have been closely monitoring the situation using a network of seismometers, GPS stations, and thermal imaging cameras to track changes in real time. The data indicates that the risk of an eruption has increased substantially. The decision to evacuate was not taken lightly. It followed weeks of intense monitoring and consultation with volcanologists and emergency management experts. The first official warning came when the Yellowstone Volcano Observatory, YVO, elevated the alert level from normal to advisory, indicating that the volcano was showing signs of unrest. As seismic and geothermal activities continued to escalate, the alert level was raised to watch, signaling that an eruption could be imminent. Evacuating an area as vast and popular as Yellowstone is a monumental task. The park spans nearly 3,500 square miles, encompassing parts of Wyoming, Montana, and Idaho. Officials had to coordinate with multiple state and local agencies to ensure an orderly evacuation. Visitors and residents were given clear instructions to leave the area immediately, with designated evacuation routes and shelters set up to accommodate those displaced. The logistics of the evacuation involved a massive mobilization of resources. Park rangers, state troopers, and the National Guard were deployed to assist with the evacuation and ensure public safety. Roadblocks were set up to prevent unauthorized entry into the park, and helicopters were used to survey remote areas and assist in evacuating those who might be stranded. The evacuation plan also included measures to protect wildlife, with efforts to relocate animals at risk from the eruption. As people left the park, scientists continued their round-the-clock monitoring, ready to provide updates and additional warnings as necessary. The evacuation is a precautionary measure reflecting the gravity of the potential threat posed by the supervolcano. Officials emphasize the importance of staying informed through official channels and adhering to evacuation orders to ensure safety. This unprecedented evacuation raises many questions about the nature of the threat and what might happen next. To understand why these measures are necessary and what exactly is at stake, it's crucial to delve into the science behind Yellowstone's supervolcano. What makes it so dangerous, and why does its activity warrant such drastic actions? Yellowstone's supervolcano is one of the most formidable natural features on Earth, both in terms of its size and the potential impact of its eruption. Understanding what makes this volcano so significant requires a detailed look at its definition, location, historical eruptions, and the formation of its caldera. A supervolcano is a volcanic center that has had an eruption of magnitude 8 on the Volcano Explosivity Index, VEI, meaning it ejected more than 1,000 cubic kilometers, 240 cubic miles, of material. These eruptions are thousands of times larger than normal volcanic eruptions and can produce massive ash clouds, lava flows, and other volcanic hazards that have widespread and catastrophic effects on the global climate and environment. The sheer volume of material expelled during such an eruption can cause long-lasting changes to the Earth's atmosphere, significantly lowering temperatures worldwide and affecting weather patterns. Yellowstone National Park, which spans parts of Wyoming, Montana, and Idaho, is home to one of the world's most studied supervolcanoes. The Yellowstone caldera, located primarily in northwestern Wyoming, is the largest volcanic system in North America. The park itself covers an area of approximately 3,500 square miles, making it a significant geographical and ecological feature in the United States. The region's geothermal activity, including famous features like Old Faithful, draws millions of visitors each year, underscoring the balance between its natural beauty and underlying danger. The Yellowstone supervolcano is underpinned by a massive magma chamber that drives its geothermal and volcanic activity. Understanding the science behind potential eruptions involves examining this magma chamber, the triggers that could cause an eruption, and the various scenarios that scientists consider when assessing the potential risks. Beneath Yellowstone lies one of the largest active magma chambers on Earth. This chamber is a reservoir of molten rock located between 5 to 17 kilometers, 3 to 10 miles below the surface. It spans approximately 60 kilometers, 37 miles, long, 30 kilometers, 19 miles, wide, and up to 10 kilometers, 6 miles, deep, containing both solid and partially molten rock. Recent studies using advanced imaging techniques such as seismic tomography have revealed a more detailed picture of this chamber, showing it consists of two interconnected reservoirs. The upper reservoir is primarily composed of solid rock with pockets of molten material, while the deeper, larger reservoir contains more fully molten rock. The magma in the chamber is a mixture of molten rock, crystals, and dissolved gases. The presence of these gases, particularly water vapor, carbon dioxide, and sulfur dioxide, increases the pressure within the chamber. This pressure builds as more magma accumulates, creating conditions that could eventually lead to an eruption. Several potential triggers could cause the Yellowstone supervolcano to erupt. One of the primary triggers is seismic activity. Earthquakes are common in the Yellowstone region due to the constant movement of tectonic plates and the shifting of magma beneath the surface. These earthquakes can create fractures in the crust, providing pathways for magma to ascend toward the surface. Magma movement itself is another critical factor. As magma rises, it exerts pressure on the overlying rocks. If the pressure becomes too great, it can fracture the surrounding rock and allow magma to reach the surface. The injection of new magma into the chamber from deeper within the Earth can increase the pressure and destabilize the system, potentially triggering an eruption. The situation at Yellowstone is a stark reminder of the power and unpredictability of nature. While the threat of a supervolcano eruption is severe, the ongoing monitoring and evacuation efforts are crucial steps in ensuring public safety. Stay informed through official channels, follow evacuation orders, and remember that preparation and awareness are our best defenses against such natural disasters. Thank you for watching, and don't forget to subscribe to our channel for more updates and in-depth analyses of important events.